Hi, everybody. Ooh. How's it going? I'm excited to be here and to tell you guys a bit about my journey. And here we go. So a little bit about myself. I'm an industrial designer, and I've lived and worked in over 37 countries. I primarily focus on designing products for communities in crisis. And that's brought me from disaster zones to astronauts. And so that's what I want to talk to you about. So space, why aren't we there? This is my question, right? I thought we'd be having hovercrafts and flying around and living on the moon by now. It's 2018. I thought we'd be rolling around in hamster balls and exploring other planets. The question is, why aren't we there yet? And it's really because it turns out it's really hard to get there, it's very expensive, and it's very dangerous. Because we can't actually bring everything with us. So what we have to do is think about how we can start building things there. So I actually started working at a small company called Made in Space. I'll let you guys guess what we did. We made things in space. So after about 400 flight parabolas, we took a bunch of 3D printers and threw them on the zero-G vomit comets, basically. And we made a lot of really expensive, horrible-tasting spaghetti. But eventually, we accomplished what we were aiming for, which is printing in zero-G. So we launched it up to the International Space Station on a SpaceX 4 Falcon 9 rocket. It's very exciting. Not many startups actually get to do the proper launch. So it was a really exciting time in our lives because we were going to change the way things are manufactured, not just on planet, but off. So this is our printer in the science glove box on the International Space Station. They have it in there because it was a science experiment. So they have to protect people on the space station in case anything goes wrong. You can't really open the window on the ISS. I mean, you could, but it would be the last time you open the window. So we have to keep everything contained. So we sent up 14 files for the astronauts with the printer. And we wanted to see how well it would work. And we wanted to also make sure that the astronauts didn't have to do very much work. So we wanted to do it for them. So we actually operated the printer from Earth. And it turns out they really liked it. So this is Samantha Cristoforetti from ESA and Mission Commander Butch from NASA. And as you can tell, they were pretty excited. And so actually, Samantha, I don't know if you guys know much about the ISS, but you don't have much time when you're up there. You're constantly working on projects, different science experiments. But what she did is she actually spent all of her free time trying to learn how to use the printer. So it was an interesting insight. And we had one more file we were going to send up to the space station because we wanted to see if there was ever another Apollo 13 moment that we could actually save the day and email a solution to space. So that's what we did. Well, what happened is Butch got so excited about it that he wanted to test out our files. So we scrapped our file and created a whole new one. Fastest ever delivery to space. We literally emailed a file to the space station and surprised Mission Commander Butch. I don't know if you guys know how prepared mission commanders are. They're prepared for everything. So it's the first time he's ever been surprised while he was up there. And so it was really exciting. And so I think it's really cool that we can do stuff for astronauts and in space, but what about here on Earth? Because we have a lot of issues here too. I don't know if any of you remember the earthquake in Haiti. Anybody raise a hand? Not too many. Okay, great. So that's just it. No one thinks about it really after the earthquake. So I actually went down 2 years after. I wanted to see what it was like. And what I found was it was as if the earthquake had just happened the day before. And I was trying to figure out what I was going to do there. I went for 3 weeks. I actually wound up staying for 8 months. And I kept finding systems completely falling apart, all for lack of a screw or a washer. And it was really interesting to me because these are oxygen mixers. So this is in the back of a TB HIV clinic. And this one part had broken on all of them. So there's about like 12 or 15 of them, and they all could have been online saving lives, but they weren't because they were missing a part. I saw the same with water treatment facilities, all because they were missing a washer. People had donated money and items, but no one taught anyone how to maintain them. It seemed to me that a lot of aid was sent down to Haiti to make people feel good about sending money to Haiti, not actually to help the Haitians in the right way. at least in my opinion. It seemed that a lot of stuff was given to them, but nothing was invested in them. And it turns out that Haitians are some of the most badass makers and engineers you can find. So this is like what the American doctor wanted, and then the Haitian doctor made a fix. And I think people should really start investing in survivors. So here's another fix in the TB clinic. They didn't have enough of those mixers, so they were putting more patients on one oxygen tank. And it turns out in Haiti that it's a lot like space. It takes an incredibly long time to get somewhere. It's very expensive, and it's very dangerous to actually pick up the supplies you need. So I made this friend, Maeve. She's my personal hero and a very good friend of mine. She risks her life every day. So because it was 2 years after the earthquake, nobody was donating medical supplies or money. And so one night she had nothing left. One night she had to deliver a baby. And so to tie off the umbilical cord to prevent neonatal sepsis, she actually cut the fingers off of her last pair of gloves to tie off the umbilical cord, which was awesome. It was a great fix. Mommy and baby are healthy, everyone's happy, except that she had to deliver 4 more babies that night, barehanded, to potentially HIV-positive women. When I heard this, I thought, enough is enough. This is such bullshit. Why is she risking her life and constantly having struggles like this? It occurred to me that maybe we could print those clamps she needed. So the next time I had power and internet, I got on FaceBrain and asked if anyone had an old 3D printer. And I actually went and learned how to 3D print in a shipping container in Haiti, hiding from dengue and malaria. So it's pretty cool that I was able to make something for Maeve, but it's only powerful when you teach others to make for themselves. So this is Johnson. He runs our lab in Haiti, and here's the clamp we made. And it's because it's a digital file, it can be shared anywhere for free. And it's now being downloaded in over 10 countries, I believe, and used. And here's the fix Johnson made. Instead of using that expensive piece to share the oxygen, he made that fix. And here he is teaching others. So Johnson's from the slums in Haiti, and here he is actually teaching medical professionals how to make their own medical devices. The really exciting thing about this is that for those small clinics to get those clamps, they cost about almost $3 each. And minimum wage in Haiti is actually $5 a day. And so you can imagine how it's very hard to get access to the things you need. But after teaching Johnson how to make the clamps and recycling to make other products, we were actually able to get them down to 17 cents. So now it's cheaper to invest in locals to produce locally. So if you're a donor, you can actually have more bang for your buck and empower communities. And since then, we've grown. Now we're a nonprofit, field ready, and we've done a lot more deployments. This is a Nepal earthquake. You can tell it's not easy to get around. We couldn't get supplies, roads were gone, planes couldn't land. And so this is our process. So we identify problems on the ground with the survivors. We never want to assume that we know what they need, because how could we possibly know unless we're there? We co-design what they need with them, and then we figure out how to manufacture it. And then we train them how to do that, and we leave the technology behind. So the most important thing is asking them what they need, collaboratively designing with them, and then teaching them how to do it themselves. And so this is what we did. So this is actually, you want to talk about going exactly to the zone of your customer, or your person you're working with, because we literally drove up to the Himalayas and operated a 3D printer off of the car to make a fix for this community. And it's exciting because this was the only things that were working in Nepal were ham radios. And they only had 2 of them in the country because the cells were down, nobody could communicate. And so what they realized is if they could make more antennas, they could get more people, to find more people. So this is a fix that a high school kid made. And so we worked with him, we did design and engineering with him, and created a much better one. And now these are actually all over the country. This is a baby incubator that was broken in the hospitals there. You don't want to put a baby up against raw metal, right? So a lot of things we do in the West is great. We donate a lot of things. The challenge is we don't teach people how to maintain them or fix them. So what we did is we spent a couple hours, and we actually CAD'd and designed a new part. So this is the fix. And now 6 baby incubators are back up online. They were originally, I don't know, $100,000 for these machines, and all for 50 cents, we're able to get back working again. This is that same community when we had the car up there. They needed these pipe fittings, And it seems silly, right? Like you just need a pipe connector. But for them, they had to walk a week down by foot to get those parts. And then they had to walk a week back, so they lose 2 weeks of income and have to leave their family. And that's if they were able to get the right part. So we thought, okay, great, we're gonna teach them how to CAD, which is what we usually do. But for people who've never used a computer, spending 80 hours to learn CAD is kind of challenging. So we realized that, how do we remove the friction? So we partnered with a university in the UK, and we actually created an app, Make My Pipe. So now all they have to do is measure the 2 pipes, and it'll automatically generate a 3D model, and then you hit print, and you're set to go. And as our model is about teaching people and working side by side, we had Ram was one of our apprentices in Nepal at first, and now he's our lead engineer. And it's kind of exciting, so I'm gonna let him tell you a little bit about one of the projects he's working on. Oh, and there's no sound.
He had an idea of a group cookie store burner, but he couldn't make it because of the level of complexity in his design. So Mr. Casey was planning to go to India to find a CNC machine to make his new design into a prototype, because no local wooden pattern maker were able to turn his product into a prototype. So when he found field ready with 3D printer in Nepal, then he came to us and shared his design idea, and then we were able to turn his idea into prototype in less than a week. This new cookie store burner has a better biomass efficiency. So it consumes less firewood and is good for environment, and also it produces very less smoke, so it's good for users' health.
So what's really exciting about this project is we use new technology and old technology to do casting of metal. So this was actually faster than sand casting. It was actually faster than 3D printing metal right now. And we were able to do it in massive scale. He actually won a contract for 210,000 stovetop burners, which means that by the end of this year, 1.2 million people will be positively impacted by this kind of work. And I really want to emphasize that teaching people how to teach other people and really sharing knowledge and investing in those people at the edges. And so now we're taking you to Kenya. So this is a fetoscope that Ram made. It's actually to listen to a baby's heartbeat, to know where they are in the position of the mother's womb before they're born, so that they know if they need to go all the way down to Kathmandu to go to a hospital. And so that's a CAD, and that's the fetoscope. And then here, you can see the 3D printed version on the side. And does everyone know what this is? This is a wood lathe. It's what you use to make like table legs and chairs on. And so what he's doing is he's actually making a wood version of the plastic, because he says it's much easier than getting 3D printers everywhere, so why don't we produce it locally? And here's the ones he made. And it's exciting because Ram is actually teaching Michael how to make them from Nepal. Here's a kidney tray that Michael made. He was trying to figure out how to do it. How can we do it cheaper, better, faster? So we made a mold, and then he vac formed, and now we have a 50-cent kidney tray, and we can make them rapidly as people need them. Next place is, this is the US Virgin Islands, so we deployed to St. Thomas. And the big challenge was, well, lots of things: food, shelter, water, power. And what we found is that FEMA had said online, hey everybody, reach out to us, we'll help you, just let us know where you are. The problem is, nobody had any power or internet, so how are you gonna contact and ask for help? It's kind of a silly thing. So we realized that power was really the thing we needed to focus on. And so this is actually a solar farm that we came across, because we kept finding broken solar panels, like blown all over the island. And I think it's interesting because they're so fragile, and they're what's supposed to be preventing climate change, what's happening. And so we kept finding garbage like this everywhere. And so we were trying to figure it out. We're like, well, maybe we can make power from these broken solar panels. Maybe we can bring them back to life. And so we did. We figured out how to take garbage and turn it into light. So with some solar panels, a little bit of soldering, I borrowed a car battery and an inverter, we were able to make solar charging stations. And we taught other people how to do it. And then we taught the teachers how to do it. So this is our partners on the ground from my brother's workshop. And they actually teach at-risk youth construction skills. So we were able to teach them how to do this so they could teach the young men. And now, the next time a hurricane hits, they know what to do before FEMA even touches ground. They know how to get power. They now can contact FEMA before they get there. This is Syria. Have many of you seen these scenes about what's going on? Anybody? Anybody aware? Awesome. I mean, not awesome, but I'm glad you're aware, because a lot of people actually don't, which is kind of shocking. So this is some first responders in Syria, and they contacted us and asked us to help them to create search and rescue tools. Because this is sadly the reality they're facing. And what they needed, so what they do is the Assad comes in and drops barrel bombs. So they actually chase the planes, so they're the first ones to the site, and then they go and pull people out of the buildings. And sometimes to save a life, all you need is 3 inches, so you can lift the building off and then yank them out. And so what we did is, it was more challenging for us, because usually we go infield and work side by side, like I said. So this we had to do all over the phone. I tried to go to Syria, they wouldn't let me. And so what we did is we said, okay, what's available? What do we have here? We can't use a 3D printer, we can't use electricity, we can't cross anything on the border, so what do we have? Well, we have bombed out cars, we have phones, and we have EMT kits. And so that's what we did. We did a lot of prototyping, we took inner tubes from tires, we took gauges, and we threw it all on a table. We had our own Apollo 13 moment. We took all the ingredients available, and then we re-engineered a way to lift these buildings off of people. So that's what this is. So the red is, we wound up making a really strong bladder out of the tarps, like the canvas off the top of army vehicles. And the rubber matting to prevent puncturing is actually made from the rubber mats in the back of your car to keep your car clean when you have mud. And then we took the gauges and the O2 tanks from the first responders. And this is how they work now. So if you guys can see how it's lifting, these bags can now lift 9 tons. Thanks. So my real hero is Osama. He's our team lead in Syria. And this is him producing all the bags. And now they're distributed. This is his team. I'm guessing no one would ever think this was Syria, considering what's going on. But you can see how happy he is. He's incredibly happy because he's able to do stuff for his community. He doesn't want to leave. He wants to stay there and keep creating. And I think that's really important to remember. In fact, we can't stop them from making things. So when they couldn't travel, they actually started creating hydroponics to grow food. They're feeding 3 families right now. And right now, I was on the phone with Osama last week, and there's a new hospital being built inside of a cave to hide from the airstrikes, because they're targeting hospitals. And there's a lot of machines that are broken. So this is an ultrasound machine that is what they need. It's absolutely necessary so they can do surgeries, they can set broken bones, and he actually figured out how to fix it. So now he's figured out how to fix it because of the power voltage situation, and he's put the info online so other people with the same machine can actually fix it themselves. And here he is last week. He just got his first field-ready shirt, and he's very proud because he's been working with us 2 years, and it took that long to get him a shirt. If you think about that, right? Talk about supply chain. And the best part about that is that our team in Nepal has been talking to the government about other projects in other countries. So now Osama is teaching our Nepali team how to make these airbag lifters, and the Nepali government is going to use them for the next big earthquake so they can save more lives. What I failed to mention is that those airbag lifters in Turkey cost $5,000. So we couldn't get a lot of them. But because we produce it there, we're able to do it for $50 each. Which means we can now do that all over the world for any other country that has earthquakes or war zones. And I'm just really excited that we're able to share that with the world. Now we're in all of these places. And thank you for your time. And if you guys want to get involved, please reach out. Thank you.